Before we move on to painting out these fuel and temperature values, let's talk a little bit about what it is we're trying to describe. Because we don't want to just paint random fuel values here. We want to have some sort of idea in mind of what it is we're describing. So combustion happens whenever we have temperature and fuel overlap. If the voxels overlap and the temperature value is at this ignition temperature or above that, then we get combustion. And so with combustion, that's where the flames come from. That's where our density will come from. We'll get burn where that's happening. All the stuff that we're talking about happens with temperature and fuel igniting. And that's why we're sourcing in those source volumes to begin with, because we're trying to get this fuel to light up and cause combustion. Now, what's a good way of thinking about fuel? The way I like to think of it is that fuel is potential energy. Everything that can burn has a certain amount of energy that it's storing. And whenever something is burning, what's happening is that that energy is getting released from that object. And so you might be able to imagine, okay, if we have 3 cans of gasoline, let's say that's represented by a fuel value of 3, we're going to get a bigger explosion, right? And if we have 1 can of gasoline, that's going to be a smaller explosion. So one way we can think about how violent an explosion is going to be is through its fuel value. The areas that have a higher value are going to see a larger or a more drastic combustion occur. Now, one thing that you want to also keep in mind as we go along here is that it also matters how quickly we go through this fuel. And so in thinking about our campfire example, we have these logs, right? The logs store a lot of energy. Inside those logs, if you were to somehow take all the energy that you can use in a log and use it up in a split second, you would have an enormous explosion. Now, this doesn't happen in real life, and so that's why logs don't behave like gasoline. But think of it like that fuel is the potential energy that something is storing, and then later on we're going to tell Houdini how quickly it should go through that fuel, and that's how we control our various combustion effects. Let's go inside of Houdini and paint out and sort of talk through what we're trying to do with temperature and fuel on this campfire. So first of all, it's worth noting that temperature and fuel with this campfire is not going to be the same value. Think, again, fuel as potential energy. That's how much energy can something release, and temperature is how hot something currently is. So let's create 2 paint sops. This one here is going to paint out our temperature, so we'll say our temperature paints. And we'll also do this separately for the logs and the embers. And we'll create another paint sop here that will represent our fuel. So we'll say fuel paint. Okay, let's hide other objects so that we just have our logs. Let's go to our background color, apply to all, and turn off this lighting by clicking that, so that now we can just focus in on painting our temperature. And before I get to painting this, let's also just take a minute to examine some reference and gather some ideas on what's happening. Looking at this, where would you say that things are the hottest? I'd say that the embers and the bottom of the logs are probably the hottest areas of what we're seeing right here. So when we're going to paint our temperature values, that's where we should concentrate most of our values. Now for the fuel, we have to ask ourselves, what areas hold the most potential energy? Towards the embers, that whole zone right there is energy that's already been spent up. Now there's still flames, there's still fuel in those embers, but it doesn't have as much fuel as in the logs that haven't been fully burned up yet. So when painting our fuel values, let's focus most of that towards the logs themselves. Let's still paint a little bit of variety in where that's happening, maybe even concentrate some of our fuel values towards the bottom. But in general, it's more in the logs. One last thing I think that we ought to take a note of is that when it comes to the temperature, the hottest area of this fire is probably right in the center of the ember bed. And so we're going to have our highest value at the center there. We'll feather it out. It still will just, in general, be higher than the temperature values on the logs themselves. And the cool thing about that is temperature, again, temperature rises. So just like you saw in Pyro 1, we're going to start with those temperature values on the embers. It's going to rise up. It then is going to hit the fuel that's mainly concentrated in those logs. And that's what's going to drive most of the effect. Okay, cool. Let's paint this out.